So we, section 4.2, we finished Friday on page 2 of your handout. And we had just gone through the signs of the sine function and cosine function depending upon what quadrant P of t and the terminal side of the angle lands falls in, okay? And so if P of t and the terminal side of the angle are in quadrant 1, then both sine and cosine are positive, right? If P of t and the terminal side of the angle lands in quadrant 2, right, sine's positive and cosine is negative. And since x is equal to cosine t and y is equal to sine t, right, we figured this out based upon depending where a point lands in a quadrant, what quadrant a point is in, right? We know whether x is positive or negative and whether y is positive or negative. So in third quadrant, right, both x and y are negative, so both sine t and cosine t are negative. In the fourth quadrant, x is negative, or x is positive and y is negative, and so cosine t is positive in the fourth quadrant and sine t is negative. Okay. All right. So we did this exercise. Now let's take a look at the exercise down below it. And we're given if sine t is equal to minus 2/3 and P of t is in the third quadrant, find the value of cosine t. So the sine of the angle t is equal to minus 2/3 and P of t is in quadrant 3. And you know that the terminal side of the angle, right, passes through P of t. Okay. So here's my unit circle, center at the origin. And you know that the initial side, right, of our angle coincides with the positive x-axis. We're given that P of t is in the third quadrant, okay? And so the terminal side of our angle passes through that point. And since we're given sine t is equal to minus 2/3, right, that's the y coordinate also, right, for that point P of t. Okay. Now, we can, doesn't matter whether you draw the angle t in a counterclockwise direction, which we have a tendency to do. Right? But we could also draw it in a clockwise direction, right? Because no matter whether you draw it in a counterclockwise or a clockwise, right, those two angles are coterminal, right? They share the same terminal side. And so it doesn't actually specify whether t is positive or negative. T could be the negative angle rotating from the positive x-axis to the terminal side, clockwise. All right. Well, P of t is in the third quadrant. So, and in the third quadrant, we know both sine and cosine are negative. So the cosine of angle t, right, has to be less than 0. Negative. So how do we figure out what cosine t is? Well, on the previous page, bottom of page 1, we have the Pythagorean identity. Right? Cosine t squared plus sine t squared is equal to 1 for every value of t, for any real number, t. Minus infinity to plus infinity. Well, we know that sine of t is equal to minus 2/3. So we we put minus 2/3 in for sine t. Now remember, when we write this, what we mean is the sine of the angle t quantity squared, right? So when I replace sine of 2 minus 2/3, I have minus 2/3 squared. Okay. Cosine t squared plus minus 2/3 squared is equal to 1. Okay. Well, minus 2/3 squared, the negative squared is positive, 2 squared is 4, 3 squared is 9, right? That's from the rules of exponents, okay, which we know now. Okay. And now, solve for cosine t. Should say the cosine of angle t. And I subtract 4/9 from both sides. So 1 minus 4/9 on the right, and 1 minus 4/9 is 5/9. And now I take the square root of both sides. Okay. So I have the square root cosine t squared is equal to yes. Class has already started. Okay, so you can take notes in your notebook. So square root of cosine t squared. What's wrong with the right hand side? Right? Because p of t is in the third, terminal side's in the third quadrant. Cosine is negative in the third quadrant, right? So what we actually should have on the right hand side is minus the square root of 5/9. Okay. And so the cosine of angle t is equal to minus square root of 5 over 3. Right? When you take the square root of fraction, you take the square root of the numerator over the square root of the denominator. Any questions on that? All right. On top of page 3, right, we have the values of the sine and cosine function for multiples of pi over 2 radians. And remember, pi over 2 radians is the same as 90 degrees. Okay. So in the first example, okay, pi over 2 radians or 90 degrees. The terminal side, wish I had a colored pen or red pen, but I don't. That angle, terminal side, goes through the point 0,1. Okay, so that's the angle pi over 2 radians or 90 degrees. Okay, and since the terminal side goes through the point 0,1, okay, this terminal side's on the y-axis. Okay, we have the cosine. Right, the pi over 2 is equal to the x-coordinate, which is 0, and the sine of pi over 2 is equal to 1. Another example, in this example over here, right, we're talking about the angle pi radians. So again, here's the initial side, here's the terminal side, here's the angle pi radians, okay? is the same as what? 180 degrees. The terminal side goes through the point -1, 0. So the cosine of pi is equal to -1, and the sine of pi, right, which is the y coordinate, is equal to 0, right? This is the point -1, 0 on the unit circle. And cosine is equal to the x coordinate, right? Sine is equal to the y coordinate. Down here we have the angle 3 pi over 2 radians, which is the same as 270 degrees. So here's the angle 3 pi over 2 radians, same as 270 degrees. And that terminal side goes through the point 0, -1 on the y-axis. And so the cosine of 3 pi over 2 is equal to the x coordinate, which is 0, and the sine of 3 pi over 2 is equal to the y coordinate, which is -1. And then lastly, we actually have two angles we can deal with in this last case. Again, that's the initial side that coincides with the x-axis. If the terminal side lies directly on top of it and there's no rotation, that's the angle 0 radians, right, which is equal to 0 degrees. 0 rad equals 0 degrees, okay? So if both the terminal side and the initial side are on the positive x-axis and there's no rotation from the initial to the terminal, that's the angle 0 radians, or 0 degrees. On the other hand, if we completely rotate the initial side to the terminal side one complete revolution, then that is the angle 2 pi radians, which is equal to 360 degrees, right? So for both those angles, 0 radians and 2 pi radians, the terminal side goes through the point 1, 0. And so for both those angles, for the angle 0, cosine, right, is equal to the x coordinate, which is 1. Sine is equal to the y coordinate, which is 0. Right, that's for both 0 radians and 0 degrees. Now for 2 pi radians, cosine 2 pi is equal to 1. And sine 2 pi is equal to 0. Okay. Both cosine of 0 is equal to 1 and cosine 2 pi is equal to 1 because they're coterminal angles. They have the same terminal side, 0 radians and 2 pi radians. The same can be said about sine of 0 radians and sine of 2 pi radians. Because 0 radians and 2 pi radians are coterminal angles, sine 0 and sine 2 pi are both equal to 0. Okay. They both have the same value of the y coordinate. So here's kind of a summary of what we found from up above. Okay. If the angle t is equal to pi over 2 radians, then sine pi over 2 radians is equal to 1, and cosine pi over 2 radians is equal to 0. That's from the upper left-hand corner up here. And pi over 2 radians, right, you know, is 90 degrees. Okay. If the angle t is equal to pi radians, then sine pi is equal to 0 and cosine pi is equal to -1. And pi radians, right, is the same as 180 degrees. And then if t is equal to, the angle t is equal to 3 pi over 2 radians, and sine 3 pi over 2 is equal to -1, and cosine 3 pi over 2 is equal to 0. And the angle 3 pi over 2 radians, right, same as 270. And up here, right, angle is 0 degrees, sine 0, or angle 0 radians, sine 0 is equal to 0 and cosine 0 is equal to 1. That's the same as 0 degrees. So these are called quadrantal angles because their terminal side lands on the x or y axis. Okay, and you can think of quadrantal angles as multiples of 90 degrees or multiples of pi over 2 radians. Okay. All right, both the sine and cosine functions are periodic. That means their values repeat every so often. And in this case, the sine and cosine functions are periodic with a period of 2 pi radians, which you know is the same as 360 degrees. Okay. So every 2 pi radians or 360 degrees, the sine and cosine functions repeat themselves. So if t is an angle in radians, then the sine of the angle t plus 2 pi has the same value as the sine of the angle t. So, now I put plus here. I wish I had created another row and did minus as well, because it's also true that the sine of t minus 2 pi radians is equal to the sine of t, and the cosine of t minus 2 pi radians is equal to the cosine of t. Okay. So t plus 2 pi and t minus 2 pi are all coterminal angles. Back in section 4.1, we said that any angles that differed by an integer multiple of 2 pi were coterminal angles. Well, t plus 2 pi, t minus 2 pi, all differ by an integer multiple of 2 pi radians. Right, so they're all coterminal angles. And so what this says is, if two angles are coterminal, the sine function is the value of the sine function is the same for both those angles. And same with the cosine function. Any questions on that? Okay. So you flip over your handout to page 4. We're going to find the exact value of each expression. Well, sine of 5 pi over 2, that's more than 5 pi over 2 is more than 2 pi radians. So from the previous page, let me do it this way. Let me put it up. So the sine of 5 pi over 2, because the sine function has a period of 2 pi radians, the sine of 5 pi over 2 is equal to the sine of 5 pi over 2 minus 2 pi. Well, the common denominator in that difference is 2, right? So this is equal to the sine of 5 pi over 2 minus 4 pi over 2. And 5 pi over 2 minus 4 pi over 2 is pi over 2. Well, we know what the sine of pi over 2 is, right? What's the sine of pi over 2 equal to from the previous page? It's equal to 1. So the sine of 5 pi over 2 is equal to 1. Pi over 2 and pi over 2 are coterminal angles. So the sine function, the value of the sine function is the same for those two angles. Next we have the cosine of 3 pi. Again, right, 3 pi is greater than 2 pi. So I can subtract 2 pi from that angle. So the cosine of 3 pi has the same value as the cosine of the angle 3 pi minus 2 pi. Well, 3 pi minus 2 pi is equal to pi. And cosine pi is equal to -1. So the cosine of 3 pi is equal to -1. Okay. Any questions on that? So that's how periodicity works, right? In evaluating the sine and cosine function. Okay. All right. So now we have the even and odd properties of the sine and cosine functions. We talked about even and odd functions. I think it was back in chapter 2. Okay. And so the cosine function is an even function for every real number t. So the cosine of minus t has the same value as the cosine of plus t. The sine function is an odd function for every real number t. So the sine of minus t is equal to the negative of the sine of plus t. Remember, the minus sign up front is like -1 times the sine of t. So down below in the exercise is find the exact value of each expression. So we have the sine of minus 3 pi over 2. Well, because sine is an odd function, right, this is equal to the negative of the sine of plus 3 pi over 2. So just to emphasize, this minus sign is the same as -1. Well, what's the sine of 3 pi over 2 equal to? It's equal to -1. And -1 times -1 is +1. So the sine of minus 3 pi over 2 is equal to +1. Okay. The cosine of minus pi, what's that equal to? Well, because cosine's an even function, the cosine of minus pi has the same value as the cosine of plus pi. And the cosine of plus pi is equal to -1. So the cosine of minus pi is equal to -1. All right. Any questions on that? All right. At the bottom of your page in the table are the exact values of the sine and cosine function for 3 important angles. T equals pi over 6 radians, pi over 4 radians, and pi over 3 radians. Pi over 6 radians is the same as 30 degrees. Pi over 4 radians is the same as 45 degrees. And pi over 3 radians is the same as 60 degrees. Okay. And all these values for the sine and cosine function can be found using geometry, using right triangles. Okay. If you want to see where these values come from, right? see me after class or during office hours, right? And I'll be happy to show you the triangles that we use to get these exact values, okay? So, but your textbook also gives you the triangle, shows you the triangles that give you the exact values, right? So, for t equals pi over 6 radians or 30 degrees, okay? The sine of pi over 6 is equal to 1/2, and the cosine of pi over 6 equals square root of 3 over 2. For t equals pi over 4 radians or 45 degrees, okay, the sine of pi over 4 radians is equal to square root of 2 over 2, and then cosine pi over 4 radians equals square root of 2 over 2. And then lastly, for t equals pi over 3 radians or 60 degrees, right, sine pi over 3 is equal to square root of 3 over 2, and cosine pi over 3 is equal to 1/2. So last week I asked you, I think it was Friday I asked you, how many of you heard of the unit circle? Just about every hand in class went up, right? So if you're familiar with the unit circle from high school, you should be familiar with these angles, okay, as well. Okay. All right. So if you flip over your page, it is 9:35. Class ends at 9:50. All right. So the unit circle is attached to this document, right? It's on page 6. Right. If those of you who raised your hand, you said they were familiar with the unit circle, right? This should look familiar to you. Okay. And then there's on page 7 and 8, right, are the same values from the unit circle, except they're in table form. Okay. So you should try to answer questions on page 5 right before class on Wednesday. Okay. See if you can figure these things out. But we need to take our quiz. Okay.